Hello guys, can you hear me? Hello.
Yes,
Hello.
we can hear you.
Yeah. So far we have discussed stack queue, then trees, heap. Now we are at like hashing or hash maps. So the thing is that hash map is something comes into a picture when we talk about dictionaries. So dictionaries data structure we have where we have like key value pair. So as long as that our dictionary is small, in that situation using particular keys we can like directly call particular means we can get particular value. But when the dictionary becomes quite huge, and some situation that means that particular dictionary or that particular table will be like empty also, means whenever we are like having like sparse entries over there, okay, means, like none entries over there. So in that situation means it becomes quite difficult to like manage everything. And in that situation whenever we have to do search operation, so it becomes quite difficult. So what we generally try to do, because whenever we have to do search operation on trees, sorry, on dictionary, because we mentioned like whenever we are we have to implement dictionary, we try to do that thing using trees. And at trees everything will be stored at different level, and whenever we have to do search operation on tree, so we need to go through each of that node and it becomes quite difficult. So if you have implemented that particular tree using binary search tree approach, and if you have like converted that into heap, then a search would become easy. But in some situation, because let's say when we talk about social media, then in that situation the acquaintances that one person having might be different than another person, that that person having the acquaintances that another person having. So in that situation what I'm saying is the child node that which are there for particular node will be different. So in that situation tree or dictionary will become uneven or like unbalanced easily, and we cannot means do that search operation that quickly, okay. And that something will increase time of accessing particular element from that particular tree, okay. But in case of the social media, if somebody's name start with like alphabet A, then he means he might be like served quickly, or he might get like access into his account quickly. But if somebody's name start with Z, then in that situation he might need to go through all those keys before reaching to Z, and that will something increase delay, okay. So to avoid that thing and to do search at constant time, this hashing thing or hash map thing comes into picture. So basically what we do over here, we try to take, because what we generally say, whenever I'm having really huge array with me, I'll try to take each element of that array. I'll try means pass it through some sort of function. Basically, I call that as we call that as a hashing function, and that hash function will convert take in that number, and it will convert it into like some another number. Okay, so let's say I'm having like 10,000 elements inside like that first array. I will pass it through that hashing function, and towards means on other end that 10,000 number I might put into like 10 back buckets or like 100 buckets. Okay, so instead of searching for like all those 10,000 elements, I can just search for like 100 buckets or 10 buckets. Okay, so this is the beauty of hash function. This is just like at high level. Okay, I'm just trying to explain this thing. So thing is that what means what we have done is we have taken all those elements, we have passed it through like hashing function, some sort of function which will means like x is something as input, it will pass to certain function f of here, and we will get output y. But thing is that our output, in some cases what happens, collision will happen between certain outputs, okay. So those two inputs will fall into same bucket, okay, and that something will increase load factor of all those buckets, okay. So in certain situation you might find like 1,000 element in one bucket, and another bucket you might find just like 10 elements. So whenever you do search related to that one bucket, where you are having like 1,000 element, you need like longer time, and that's like quite adjust about is quite adjust our objective. So that's the reason we want to avoid that collision, and that's the reason we implement this hashing thing on something which is quite unique. And the unique thing that we are having is like dictionaries, because in case of dictionaries we have like added one condition that all the keys should be unique, okay. So when we take in that key and when we pass through that hashing function, the value that we are getting at output will be different. Okay, so we are ensuring that all the keys which are getting into that hash function will be like having different buckets, and that's how we can do this search thing quite easily. So this is the first thing. Okay, so means you need to understand why exactly we are trying to implement this hashing thing or Hashmap thing, because we want to do search operation at constant time. Means whatever size of my input, search operation should happen at constant time only. Okay, means it will be like 10 elements or 1,000 element or maybe million element, it should happen at same time. So to ensure that thing, what we do, we try to take all those keys, because and we pass all those keys through that hashing function, and we will get certain hash values. Okay, so out of that hash values we will create a new dictionary where this all those hash values will act as a keys, and then all the values that we were having in earlier dictionary, we will store them as like key means values only. Okay, and in that way, instead of like looking for all those 10,000 element, we need to look for like minimum number of elements only. Okay, because we are creating some sort of hash values over there. Okay, and this hashing function can take in a string as an input as well. Okay, so it becomes easy to do that thing easily, because we are creating bucket, and inside that bucket also you can create it like hash function within a hash function. So basically process of applying passing input through hash function is called as a hashing. And using that hash function you will get hash value, and using this hash value and the value, we can create a hash map or hash table. So hash map is something help us to do this searching operation at constant time. Okay, so now question is how to implement that thing. So whenever we have to implement this hash thing, so first of all we need to create table. Okay, for all those things. So basically I'm creating like one table uh, of like just to store all those hash values obtained with none data type. So I'm creating that cell dot table, then I'm just printing that table. Another method to print that table. So first operation is like we have to store, first of all we have to create that hash map, and then second thing, whenever we have to access element, we can directly access it from hash map. So first thing what I'm doing is, there is one string, that's something coming that's something is for like particular key only. Okay, so I am taking that string as an argument, passing it through that hash function, I am getting that hash value. Okay, so some hash value is being created, then I'm checking whether hash value means minus one is like means not possible, or like not there or something like that. Okay, so what means, what exactly we're checking over here is like whenever hash value is present. Okay, so or in that situation I will go inside this loop and I will check cell dot table. So basically I have created this table of like 10,000 element, and I am checking this particular index location which is created once we pass that thing string through this function, hashing function. So what I'm checking, whether there is any element in that at that particular index location or not. Okay, so index location is something should be represented by this hash value. So I'm checking whether there is any element or not. So whenever there is an element, I will just append that thing with this string. So basically we're checking whether there is any bucket or not. If there is a bucket, I'm adding one more element, or like basically I'm adding one more value to that bucket. Okay, but thing is that that bucket can be accessed using this key HV index. Okay, so basically we are representing that thing as array, right? We are taking tree, we have represented the tree using key values, and then I'm passing that key through hashing function. I'm getting hash value, that hash value will act as an index in this array, and then what I'm doing is I'm creating list within list, as like you mentioned at the beginning, and then I'm like creating means like more element inside that bucket. Okay, so if that bucket has already been occupied, if that were not the case, then I can just say like that bucket is means that particular index or that value equal to string. That's something we wanted to like add over there, right? So this is how we can create hash function, and we can means we can create hash maps. Okay, so HV is like key or index, and then a string would be like our value inside that array. So that's how we take in tree, we pass it through hash function, and we get it converted into arrays. Okay, and now we can do search operation quickly. The next thing is lookup. How to check all those elements. So again, we are going for same thing. Whenever we have to do lookup, we will take that string as an input. We will convert it into hash value. Basically, that's how we are getting index generated. We are checking like this hash means whether hash value has been generated or not. then I will check like whether there is any element at this hash value location or not inside that array. If yes, then I will perform this operation. String within means I will check all the elements inside that particular bucket, because what I was saying, like basically I have created bucket over there. Okay, so basically it's like there is one more list at that particular location, and I can create like hash function within hash function. I can get that thing done as well, means implemented as well. So basically this is a string. So basically I will check string in entire that bucket, and whenever it's there, I will print we have found it. Okay, so whatever string I have provided as input, which has a hash value over there, so if it's there, then it will say like we have found it. Otherwise it will say -1, there is nothing. And then this final thing is to calculate hash value. Okay, so there are ways in which we can calculate hash values. So basically I'm just taking like a simple approach. 0th element to be multiplied by 100, and then first element should be as it is. Okay, and then that something will give me some value, and that will be like as considered as like final value. But in case of the hash function, like there is some number multiplied by 131 or 10 raised to 131 or something like that. 2 raised to 1, 2 raised to 131 is something we use as like some sort of multiplier over here. I'm not sure about that thing. I'll let you know about that number, but there is like some specific number is something we use, so that all the values that we are getting out of hash function are like unique, as long as we are dealing with strings. Okay, so that's how we write down this hash function, and this is something we as a programmer decide how exactly we want to write down that hash function. It will be different in different applications. And then I'm just like creating this hash table. Once that hash table is creating, I'm storing this my name into that. So basically Mayur is like key, I'm storing it over there. So basically Mayur is something will be taken in as a key. Then I'm storing it over there, and whenever I say like lookup, so I'll means that thing will be like found, and whatever value there will be returned. Okay, so that's how means we have found it. So this thing will happen at constant time only, but this is how we can create hash map. So first of all, the first thing that we need to do is we need to take tree. We need to think about a way in which how means how can we convert that tree into array. So first of all, we have to create empty array for all those keys, and then we can just like store all those things over there. Okay, and using that thing, like we can get our task done very quickly. First of all, we need to create hash maps, and using that hash maps we can get particular search done quickly. Okay, yeah, so that's all about hash maps. I hope that thing is clear to you. The next thing that we are having on agenda is graphs. I hope this thing is clear to you. Hash maps thing.
Yes.
The next thing that we are having over here is graphs. Okay, so graphs is like again non-linear hierarchical data structure where elements are like we are having a different level. So thing is that graph is similar to trees only, where we have like having number of nodes, and it's only different from tree in certain characteristics only. Okay, so in case of the trees, we are having sense of having like start node. Okay, we are having like a root over there. In case of the graphs, we don't have like that starting element. Second property that we were saying inside tree is like in case of the tree we cannot cycle through structure, whereas in case of the graphs we can cycle through entire network. Okay, and third thing is in case of the trees we were just having access to our child, means we were just carrying references to our child nodes, but in case of the graph we can also carry reference to our predecessor and to successor. Okay, so means that's something here we are really not doing any distinction, rather we are storing that thing in terms of ages only. Okay, at least as long as this implementation comes, but there are like other implementation as well in which graphs can be defined. Over there you can like define predecessor and a successor differently, and you can get this thing done. But I'm just talking about like basic properties. Okay, so whenever you have to implement this graph, first thing that you need to do is you need to create nodes. So each basic element inside the graph will be considered as like vertices. All those vertices can be connected to each other using edges. So these two elements is something you need to define first. Okay, so for each node you need to add value and edges to, it could be to predecessor node, or it could be to like successor node. Okay, so these are the two things that you need to define, and whenever you have to perform thing, then I will just means we can just create like one more additional variable visited. Then we can create like one more object age, and for that age, we need to provide where exactly that age is starting and where exactly it's ending. So starting node and ending node is something we need to provide as input, and based on that we can like get this means age develop. Okay, so these are like basic classes that we need, or basic object that we need. First of all, we need a class to create node. That's something will hold information about value that we want to store at that particular vertices, and its connection to adjacent nodes in the form of edges. And then we'll need age class to store information about that particular age, where exactly it's beginning, where exactly it's ending, and we can also store information about that particular age only, weight of that age. Okay, so weight and direction of that age. Okay, so value can be like of two type. It can also store information in the form of like, because weight is something we can store in the place of value, and direction is already perform means given over here. Okay, node from or age from this node to this node. Okay, so it's like already directed graph, because there are two kind of graphs that we generally talk about, mostly talk about, directed and undirected graph. So that's about, these are the two things that we need. Once we are done with these two things, once we are sorted in terms of like node definition and ages definition, we can go further and we can define our graph. So first of all, what we need to do, we need to add like some sort of elements like nodes and edges. So that's something we have done, because when we talk about graphs, what we need, what are the things that we need? We need a node, we need age, we need name of the each of that node, and we also need means map is something like uh, unnecessary thing, or means it's like it depends on like whether we need in our particular application or not. But yeah, that based on that we can create like map out of it. Okay, node map. But yeah, so these are the three things, that's something we need for our application. So what we are doing, firstly, using this method we can create like node names like list. That's something we can, so we have to like provide all those names as the input. So when you go to implementation of a star or like Dijkstra, or whenever you have to perform any algorithm related to global planning, so in that situation you need to take in all that information, all the data related to cities, and you need to create graph out of it. Okay, and once that graph is ready, then you need to go for implementation of BFS, DFS, Dijkstra or a star search. So that's the reason you need to know how to create graph. So first of all, you get like, you use this get names method, and using that methods you can create like you can take in names of all the nodes. Second thing is like you can there is a method to insert node over there. Okay, so basically what I'm doing is I'm just calling that class, means I'm creating instance of node over here, of class node over here with certain value, and that new node will be stored over here, and I'm just like appending this node variable that I'm having over here. Okay, and then this node map is something like tentative thing, like I'm just like maintaining this additional dictionary as well. Okay, so this is how I'm adding node to that particular graph, and then inserting age. So we need to mention all those things, where exactly this node is starting, where exactly that node is ending, sorry, age is ending. And then once we are sorted about that thing, we can like just with those values we can just create age, and that will be like new age, and that age will be like added to our this age variable. Okay, and that's how we can keep like track of all the ages that we are having inside our thing. So now we are sorted about all the nodes, we are sorted about all the ages, we are sorted about all the node names. So we know how to like define name of all the nodes, we know how to add node, we know how to add age over there. The next thing, important thing is like how to develop, means things that like all those nodes are connected to each other. Okay, so first of all you need to define adjacency matrix. So that matrix is something will be like, there you will have like all the nodes as a rows and all the nodes as a columns. And then whenever there is a exist any connection between node which is on like row side and node which is on the column side, means at that cross section of that row and column you can put one. Okay, and using that zeros and ones you can create like adjacency matrix. Okay, so these are like just additional thing to like name that list and means age and all that stuff. But the important thing is this adjacency matrix. Okay, so basically you will create like 2D matrix with rows is equal to like number of nodes, and columns is equal to number of nodes only. And using this thing you can create adjacency matrix first. So first of all you create like this matrix first, okay, for in range max index. So max index is like basically means all where means which is equal to like all the nodes, okay. You get this adjacency list, and then using this like means you get that thing developed, okay. Means basically you are just storing like all the nodes and all that stuff, and you are getting this list adjacency list developed, and this is where you are getting like this adjacency matrix developed, okay. If you go through these methods you will understand like how to get that thing done. But this is like third important thing. First thing is like you need to keep you need to have variable to keep track of nodes edges. Then you need to have method to add node, you need to have method to add edge, then you need to have method to create adjacency matrix. So adjacency matrix could be like any matrix where you means it is a 2D matrix, okay. You can like create this sort of matrix, and whenever there is like edge exists between two nodes, you can put like index to be like one, means value to be one or at that index location, and there or not. So that's how you create in adjacency matrix. So that is the third important thing, okay. First is a node, how to add node. The second thing is the edge, how to add edge. Third thing is getting names, and fourth thing is generating this adjacency matrix. The next thing is a connection matrix. Basically that's where means you try to have, basically we have added weight of all those edges in terms of value only, but you can also create connection matrix, connectivity matrix out of it, okay. Because when we talk about global maps, so in that situation we are having distance between cities. So whenever there is a connection between two things, we can put one over there, okay. But when we need distance between two cities, we can get that thing using like that value at that connectivity matrix location. And then there is a finding node and clear revisited, and then this is function to go through that graph, okay. So day phase thing is something where we need to mention start node, and then we can use like day phase approach. So there are two kinds of approach to traverse through the data, like depth first approach and breadth first approach. So in case of the depth first approach, we will consider one node, and then we will consider one node in case of the depth first approach. So let me draw a few nodes quickly. Okay, so if you consider this to be like a starting node, then in case of the depth first approach, we will means first of all we will check adjacent node to this node. So we will go over here or here, either of that position. So whichever we prefer as the first node. So basically we need to consider like that stack and queue kind of thing, okay. And then means all this out of this all the adjacent node we will create either stack and queue. So then we think about like that last in first out or first in first out, okay. So based on that, like we can create thing. But thing is that in case of the first approach, we will consider one node, and then from that node onward, we will again consider what are like adjacent node for that node. Okay, so this node and this node. Then we will check this node and this node. So this is like final node, or this is node where we want to go, or this could be like destination. So that's how I'm reaching to this thing. Okay, so thing that you have to see is, first of all I check all the adjacent node, and for that adjacent node I check all the nodes adjacent to that, and then all the node adjacent to that until we reach like some location or some dead end. Then we come all the way back, and then we check second node, then we check third node. And that's how like means first of all we try to go in this depth. Okay, so that's the depth first approach. And then there is a second approach. In that situation, what we try to do, we check this element first, and instead of going for this node, we check this node, because we are going breadth wise. Okay, so and this is like, then we check this node. Okay, so this is how we think about this entire thing. And using depth first approach and breadth first approach, so these are the approach which are used in like industry whenever we have to traverse through graph. Okay, So, and these are like basic approaches that are used, and using these approaches only we can go further and we can implement Dijkstra algorithm. So Dijkstra algorithm is one where we are having like sense of weight between these two nodes, okay, and we are going for that node where distance between these two nodes is minimum. That's the Dijkstra thing. But here only we are considering distance from starting node. But if we have to reach here quickly, we also need to choose that node which is at shortest distance from this node. So we also add that distance and as a heuristic distance, Euclidean distance between this node and this distance, and that's something will be considered as a A-star algorithm. Okay, and that's how we get that thing done. So A-star algorithm is quite efficient algorithm when it comes to getting global path between two nodes. But yeah, these are the things. That's how we can like. That's how we can get traversing done quickly. Okay, and we can get like path between all the things. And yeah, so if I run this thing, like I can get like this sort of graph generated with like this values and like this all the starting and like all that stuff, adjacency matrix, and like if I were like looking for particular element, then that element will be delivered to me. So yeah, that's all about graphs. So in case of the graphs, you need to think about how to define node using particular class template, how to define age using particular class template, and then you need to go for third class where you will like means you will call all those class or templates, and you will create like first of all you need to create nodes. Means you need to see how exactly you can insert node, how exactly you can insert ages, how to create like node names, and how to create adjacency list. And once you are done with these four things, you are like mostly done with like this graph development, and then you can just print that graph, or you can yeah, you can do search through that graph. But that's all about these graphs. I hope these things are clear. First create classes for nodes, then ages, and then inside graph create four more methods to insert node, insert ages, insert node names, and insert or to create adjacency matrix. And once this is done, then your graph is ready. Okay, so that's all about graph. I hope these things are clear to you. Kripanshu, Lucky, are these things clear to you?
Yeah, like it's clear. I'll go once again go through this, and then if I'll have any doubt, I'll discuss with you.
Yeah. And there are other implementation as well, okay, when it comes to graph, okay, because the thing that I told you, like you need to have class for node, defining node, defining age, and then inside graph you can just call like four more methods to create nodes or insert node, insert age, and then to create node names or generate node names, and then one for adjacency matrix. When you put all this together, you can have graph. And then for depth first and breadth first, that's a different thing. But yeah, it means using all these things, you can create graph thing done. Yeah, so with this, we are done with like all the data structures. And the next thing is like algorithm stuff. So I just name like important algorithm which is like relevant for us. So first is like this sorting of algorithm. So there are certain so first of all, try to understand what's meant by algorithm. So algorithm is basically textual representation of logic that we can use to solve particular problem. Okay, so it's just a textual representation of logic to solve particular problem statement, so that we could use computer resources efficiently. Okay, so that's basically algorithm, and it can be implemented in any programming language. Okay, so there are certain problems which are really important, and based on that, we are defining this algorithm, means classifying this algorithm. First is the sorting algorithms, like you will see quick sort, merge sort, or like yeah. So these sort of algorithms. So basically, in sorting, what we try to do, we try to arrange number either in means ascending order or descending order. So that is the sorting operation. If you go for like list, then it's basically putting it in ascending order. But that means the sorting operation is something we do to sort number in ascending or descending order, because that is the important thing. Because when we have to go for search operation, so you know like how exactly we read particular when we have to look for like number inside of that phone book. Okay, not I'm not talking about the one that we are having inside our mobile, but I'm talking about the one that we used to have earlier when we used to like use that like telephones and all that stuff. So we used to like check alphabet starting letter, and then based on that we used to like open that dictionary. Okay, so it's quite similar to that. So once our entire data is sorted, then only we can perform searching quite quickly. So sorting operation is something you need to sorting algorithm is something you need to learn first. Then second thing is searching algorithms. So searching algorithm is something help us to look for particular element inside that data. That's the second thing. The third thing is searching is something help us to like look for the particular element. Third thing is divide and conquer operation. So basically uh, getting bigger statement, putting it into like divide it into smaller things and getting that thing done. So that is like divide and conquer operations or algorithms. And then there is a dynamic programming, and then there is an algorithm which operate on strings, operate algorithms which operate on graphs and trees. So these are the algorithms that you should study. And when you put together the data structures and algorithms, so data structure is helping us to arrange or organize data efficiently so that we could get that thing done efficiently. Means we could like store, organize, process, and access data efficiently and quickly using our resources. I'm talking about time and space. And when we talk about algorithm, that's something also help us to like expedite this process of like going through that entire code and getting that task executed quickly. Okay, so when we put together the data structures algorithm together, we can do code optimization very quickly. But thing is that once we things that quick code optimization is we can do, but this is something we can do for like a lot of means when we have to solve complex problem, we can write down code and we can do it in like multiple ways, but we need to go for like the code which is like optimum one, and for that we need to have like some sort of index over there or like some sort of measure over there. So big O notation is something we generally we use to like measure performance of our code. There are two things: time complexity and space complexity. Time complexity is something how much time our computer takes to execute particular code as the size of input grows. Okay, so that's the time complexity. And then there is a space complexity. It's similar, but it's like how much space our computer takes as the size of input grows. Okay, and both of these things can be measured using big O notation. There are certain ways, but big O notation is something used quite generally. And then inside that big O notation, means what we do, we take like whenever we have to represent that thing, we take big O, and inside parentheses we put like some algebraic expression, and that algebraic expression generally represent like means what is the complexity of our code. Okay, and using that complexity value, we can distinguish various or like compare various codes, and we can say okay, this code is our best one, optimum one, and this is something we need to be implemented, because we eventually want to have code which is like from which we can get inference faster, and from which uh, for which requirement of storage is like minimum, because we want to deploy this thing on like edge devices like Jetson Nano or something like that. Okay, so that's the reason we need to do code analysis thing properly. Okay, so that's all about time complexity analysis, or like checking the efficiency of our code. Okay, so here I'm like just added one thing to show you how exactly time complexity can be calculated. So thing is that here I have added one code. Here I'm defining two variable a0 is 0, n is equal to 10. Then I have created one for loop. Inside that for loop, I'm just is adding that I to a0 for n number of time, and then I'm just printing this a0. Okay, and I'm just checking time means start time is something I will store inside ti variable, and stop time should be stored means we stored inside tu, and based on that I will get like time in means time to execute this entire thing. Okay, so if I have to like calculate time complexity, then what I'll do, so these are the two operations. That's something we need to perform each time this code will be means when we have to execute this thing. So one operation, two operation, then three operations. So this is like three, and then for each this for loop. So here this for loop means we are having like one instruction over here, and that instruction will be repeated n number of times. Okay, n minus one time. Actually, we are starting with one. So n minus one plus three. Okay, since it is just like one line, if you consider like second line, 2 into n minus 1 plus 3. So this will be like this many operation we need to perform in order to get this execution done. And storage space requirement will be like just two only. Okay, because we are storing it in two variables only. We also need like one thing to like keep track of this I. But yeah, but thing is like 2 n minus 2 into sorry n minus 1 plus 3 is something like we need over there. As size of n grows, the time that we need to execute code will differ. Okay, so if I just like implement run this thing, then you can see like it's 0.20 point not 207. But thing is that there is approximation thing, and if I when I increase this second line, so basically it will become earlier it was n minus 1 plus 3. When I comment out this thing means uncomment this thing, this line will be performed. So it will be 2 into n minus 1 plus 3. Okay, so that loop will be inside that loop, this action will be also performed for that many times. So that's the reason execution time has increased from 0.0020 to 0.0034. Means 0.0014 second is needed additionally to perform that code. That means our execution is become slower just because of this one line. So that's how means we consider all that stuff. I'm really not keeping track of like storage space right now, but yeah, means it will be like just same a naught, n, and I. So these are three things. Means between these three things only. But thing that I'm trying to tell you is that as the size of n increases, this thing will also change, because here I'm just considering it to be, it will not change that much, okay, because eventually we need to do approximation.
Just one more thing, like Mayur, like it also depends on the system also, like what system we are using,
Obviously.
and suppose like how much storage that we have. All those things also take into consideration, right? Like
Right.
for this execution time.
Right, because when we talk about means all the operation that we need to perform, so means 2 into n minus 1 plus 3 is like number of operation that we want to perform. But then for our CPU, there is a processing speed, right? We talk about 2.6
Right.
gigahertz or like something like that, right? So that's the processor speed. So means that many operation can be performed per second. Now we are having processor where we have like speed of like 2 tops or 3 tops. And then that many trillion operation can be performed per second. Okay, but thing is that if we like take that as like denominator, we can get like operation that can be performed, means time it take to perform one operation, and if we multiply that thing with 2n minus 1 plus 3, we will get like our actual execution time. So obviously number of, means the way we are like writing this code and the processor that we are using, that's something will decide like time complexity and space complexity.
Okay.
The way we are organizing this code. Yeah, thanks a lot for means reminding me that thing. But yeah, that's something I forgot. But yeah, means these are the things that we consider when we do this time complexity studies. But when you are given particular problem statement, what all thing you should mention is like, okay, so what's my problem statement, clarifying that thing. The second thing, getting idea about proper inputs, output, the what operation that you want to perform, then like test cases to test your code, then doing brainstorming to get that thing done, what algorithm I should go for. Then fifth thing is like you should mention like what is the complexity analysis, means optimization stuff, then debugging, writing code, debugging, and then improving further. So that's how you should approach any program. Okay, yeah, so that's all about these data structure algorithms and how exactly you should program. So this, with this I would like to conclude our entire Python thing. Okay, so in first program lecture we discuss about pcap principle, how exactly we should think about programming at microscopic level. In second lecture we moved further and we discuss about programming styles, that imperative, functional, or object-oriented programming. We discuss about processes, static process and dynamic process. And in last lecture and this lecture, we thought of, we discuss about how exactly we can get like efficient data structures and efficient algorithms, and how to do this efficiency analysis. And yeah, so that's all we need when we try to develop any sort of Python program, or when we try to solve any particular kind of system. I hope all these things are clear to you. Is there any question at this moment? If not, I have to jump into another meeting.
No.
No, from my side.
Okay. Yeah. Thanks a lot. Thanks a lot, guys. Bye. See you on Wednesday, maybe.
Yeah, sure.
Yeah.